Hello again, everyone. Glad to see you all found the links again. They're up there. Add yourself to the notes if you'd like something to talk about as far as quick reports. Add yourself attending. As far as agenda today, I think we could probably finalize the discretized logo. Quick mention about the October seminar. Lindsay, when is that happening?
So that'll be on the 14th. Let me just check the time. We're planning for a 2 p.m. Pacific, if that works with folks.
Cool. And then also it was brought up on Slack about alternating meeting times for to allow people from the eastern side of the globe to join in. So we can talk about that and maybe see if we can come up on if there's any other time that also works that we could alternate between this and some other time. So I know what's on the agenda today, but in the meantime, we can get into some quick reports here. John, what have you been up to? Whoever just added themselves to quick reports.
I finally have Kubernetes running with Dask and with the parallel with the tiled code. There's the one thing I just couldn't do is I don't have it running with Paradiso. I'm just using Cholmod right now because I just got to find out how to put that MKL library on the image, and then we can run Paradiso on there. But yeah, Dom, everything stays on its pod. It just brings back the vector when we do for the sensitivities. Yeah, it runs actually pretty slick. It's pretty cool.
So do you have to modify a bunch of stuff, or it's just I kind of lost track of where you were at with this?
Well, it's like I'm just trying to invert like larger projects. The thing is like if we're going to go larger than most of our just like our tests and examples, we are going to have to kind of modify things. Dask seems to complain when the graph gets bigger or when objects are a bit bigger than even like 200 megabytes. And it does actually seem to slow down when things get a little bit too big. For some reason, I don't know, even if your network's fast, it still seems to be a little bit slow.
And if you use the futures, right, you've sent stuff. Yeah, you've stashed all this stuff on the workers.
Yeah, and then so when you do that with larger objects, it complains also that you should be scattering them. However,
okay,
I do the recommendation, and it's still faster to just do the futures and submit them individually than trying to do scatter. So yeah, I guess I've been playing around there, but what I've found the solution is going to be is, yeah, it's just going to have to be like its own kind of little service. You send it and where the data sits somewhere on the network, and it just pulls the data that it needs and kind of like fires up the simulation on its own, not passing it. Because even if it's just the operators, as soon as you hit like 200 megabytes, it seems it starts to complain and slow down.
Does a worker hold the simulation, so it has to recreate it every time?
Yeah, so I find if for it to not complain, it has to generate it itself. Like you're not passing the misfit function. You're kind of generating the simulation and then just pulling out what you need and then just sending that back. So
that's a lot of redundant operations, though, right?
Yeah, that's kind of the pain, but that's the only way to get it to go faster. It's not more efficient, but yeah, just passing around that much. Dask is just not into it. I think we were trying some stuff with Spark even and getting the same thing. They just don't like when the graph gets too big. So
I started juggling with the idea that mostly, that's kind of a different way of talking about, but if you're on a local system, it kind of makes sense that since the parallelization is only going to happen with Paradiso, that we would trigger things in series, like all your tiles in series, because it's going to be maxing out the CPUs anyway, right, on the solver. So
yeah, exactly.
Doesn't make too much sense to fire them all at once. Anyway, that's cool. Yeah, great.
Yeah, it's pretty awesome actually. We've had some requests for doing DOIs on big surveys, and yeah, just sending the code and just having it all launch on each node, and then just pulling back what you need is kind of pretty awesome. But
yeah,
I guess that so far it works really well for that. But yeah,
you said inversion. Yeah,
exactly.
It's a lot of JVX happening.
Okay. From my end, related to SimPEG stuff, discretized stuff, I've been getting back into the cross gradient pull request review. It's I'm pretty much there. I just think I'm gonna have to add some more tests in there for it to make sure it's hitting all the lines that I want. And then I'll just take care of that myself and do it. And then on the discretized side, I finalized the nodal based interpolation for those tetrahedral meshes. That's the easy one. And then in the process of finalizing the edge and face vector interpolation ones, they're a little bit trickier. And this is just a tiny bit trickier. The point is we're interpolating vectors. I'm treating it as we're interpolating vectors to points, because that's what we use. Those like face X, face Y, face Z interpolators. So it won't be just a general face to point. It'll be vectors defined on those faces and edges to points, which is what we actually need. Yeah. Uses it. I just found some nice linear basis function for those edge and face vectors that work well. Yeah, that's what I've got for this week. Lindsay.
Yeah, just a couple of quick items. So I put the Google Doc link in the notes for the October newsletter, because October is coming. And so if folks have any items you'd like to see included in that, that'd be great. I'd like to get that out early next week so that there's plenty of time to advertise Sheehan and Jaja's seminar in mid-October. And then the other one I just wanted to resurface quickly, because I think this is a quick item and we've talked about it, but haven't made any action or taken any action on it, is Dieter brought up a while ago the right to forget with YouTube videos of our meetings being posted. And we sort of talked about it and I think had a general consensus that this seems like a good idea. We had talked about sort of like a multi-staged approach, thinking about that and thinking about managing that. I feel like that's just gonna get complicated. So my suggestion is, why don't we just make them unlisted after 1 year? That way, if there's links to them and there's some reason that like this seems like an important video somewhere on the internet, it can still be found, but it's just not advertised and not like super discoverable. So we're not deleting anything. And then the overhead management is just, there is 2 states that videos can be in, is either public or unlisted. Just wanted to get, yeah, thumbs up or thumbs down if anyone has concerns with that. All right, I will take that as a yes, and we'll go for that. And it'll probably be like once a year, I'll just throw something in the calendar to do that. So some videos will be out longer than a year, but roughly a year timeline. That's it for me.
Okay. Dieter.
Yes,
Now
I
that you're
thought I
back on
could.
the swing of things.
You hear me? Yes.
Yeah.
Yeah, for the quick report, I participated in the Schmucker-Weidel colloquium, which was originally called the Elektromagnetische Tiefenforschung colloquium. It's a biannual event of the German EM community that this year the first time happened online because of the pandemic, but usually they go to a place and meet there. And I had a discussion about standard deviation, misfit, and random noise, partly what we discussed, and I discussed stuff with the Terrasus and here at TU Delft. So it was quite interesting. There were max about 40 people in the room when we had the discussion, so quite a big crowd. And there were a couple of outcomes. One is that actually a lot of people think about it and are not sure which way would be the best. But then you had two camps, and one was like, yeah, if you do synthetic studies, you should really think about it and do it correctly. And then all the practitioners kicked in and said, but it doesn't matter because we have so little idea even about our noise floor and about our error level, that all these little things in the end don't matter that much if you have real data. So you had kind of the two things, the ones that said, yeah, if you test code, you should do it right, and the other side, but in the end, it doesn't matter. So it was kind of interesting. Thomas Günther was the host, one from the PyGimli, and he also said like they just add noise plus relative error times data like SimPEG did, and he thought most do it like this, just because it's way you often see it. And then there was I forgot his name, from Uppsala, and he said he was the only one who stood up and said their code always used the quadrature, addition in quadrature, their code. So there exists both, but no one, I would have been interested if anyone ever did a test, what would be the consequence in an inversion, but no one did. So yeah, but it was interesting. So it was not just me bothering people that are really everywhere. People think about it, but then because of lack of time or nothing is published, and you just continue what you always did. So it seems to be a general thing.
Was there like a carry key or there kind of?
No, there was Klaus Spitzer, Andreas Junge, Tilman Hanstein, what is it, from KMS in Köln? So some well-known name in the German area, but no one from the US side. It's really kind of Germany, Sweden, Poland. It's quite a Northern European focused community. Yeah. There
So
are
you
still
think-
some talks in German, for instance. There is a mixture.
So you're thinking about it, Dieter? Are you gonna make it a research project?
It would be interesting. I don't have any plans now, but
No.
I think it would be. It would be interesting more on academic level, I think.
Well, not just sure, man. I think we all need it.
Yeah.
We need a standard. You know, we need to show what the differences are, as you said, and prove like one way or the other, right? It's fine to everybody's like have their own opinion. Maybe this, maybe that, but until you really drill down to like a concrete example, like.
And actually, in the preparation of all this, there came a fourth topic that we started to discuss often, is why do folks use amplitude and phase instead of real and imaginary? And Everett's guess is that earlier on, you had not enough confidence in your recorded data, so you just used the amplitude because that was the best thing you had. At the late, you got more confidence, so you added phase instead of maybe switching to real imaginary, which would be easier to weight. Well, they have the same weight, right? And amplitude and phase, you have this problem of weighting. So I think there is the theoretical, the practical dimension already too. There's the historical dimension, and then EM has so many different methods that you also have a methodological dimension, and then it becomes very complicated to give a single answer, I think. But it's definitely interesting. And I didn't resolve anything. I just I just realized that it is interesting. So,
Yeah, it's a hard research question because there are so many factors comes in. Even if you prove like a certain way is theoretically correct, and like it's very easy to say somebody, oh, in practice you actually don't know the noise what is the noise function, then it's hard to defend, I guess. So
yeah.
like a little bit of Pandora box to open, but yeah, it's interesting.
That's why no one wants to touch it.
Yeah, it's like an uncertainty in the inversion.
I actually I tried, for instance, for the standard deviation, I tried to dig a bit papers, what people do. And most often it's not even defined. They say we have a weighting matrix, and it's 1 over the standard deviation, usually diagonal, and that's it. So then you could define your standard deviation however you want it. It's not even specified, which is probably also bad for reproducibility concerns, but yeah. Yeah. And maybe even many don't know any longer what is in their code. You would have to go and dig and see how was it implemented.
That could potentially be the case.
yeah, that was me. Devin, you can shoot.
Yeah, go ahead, Devin.
Sure. So yeah, I've been working on a few things lately. And I recently had to do just a clean install of my Anaconda and ran into some pretty common problems that I think some people have encountered, especially if you're a Windows user. So one of them, and I think Thibaut made an issue with this, was the simple regularization breaking. And it turns out it's happening when all the cells are active. So this is why it wasn't breaking on the tutorial example when I tested it, is there was actually topography, so there was inactive cells. But for this example, it was no bueno. So this could be a pretty easy patch to bring in, almost like a one-liner. If all the cells are active, we just say, okay, here's the active cells model for that. Another thing I found was I'm working with a frequency domain EM simulation I just want to run it on my laptop. I'm not trying to do any inversion, but I did want to get a nice plot as a function of frequency. So I wanted to do a forward simulation at quite a few frequencies. And if I'm, as the code works right now, just in the standard simulation class, it's going to store all the factorizations of A inverse. So I wanted to just introduce a really basic forward only keyword argument like we do with the MAG problem, where it's not going to store those factorizations. So I know that there's some really great stuff happening on the tiled simulations branch, but as of right now, this would just be a really simple option to let me do this without really impacting the code whatsoever. And the last thing was about the Pymat Solver. So we usually we're getting people to downgrade, I think PyMKL to an older version to get Pardiso to work for that Pymat Solver package. And I found out that for Windows, the modern installation of everything is it breaks because it can't find a DLL file. And so, I mean, I just kind of went into my Python packages and I just sort of hacked that one line to get it to find the actual, the DLL file that it wants to use. So I know Joe is working on an improved implementation to connect this to SimPEG, but for right now, that's sort of what I found is a bit of a solution. It's kind of ugly, but that's the reason that it's breaking. So I think the first two cases for that the forward only for frequency domain EM and the really simple fix for if all the cells are actives in that simple regularization, I'd like to bring that in as a pull request pretty quickly because I don't think it's going to impact anyone else's work and it's very lightweight. Yeah, and then
sorry,
the last thing.
Jump in for one question. I was just wondering more like a naming question with respect to the forward only. Do we want to call it store factors? I could see cases where if you, depending on the problem setup, maybe you don't want to store all the factors or we come up with something more clever, but it's not in the inversion. Just to be a little more explicit about what that flag is doing, because if it's only triggering changes on the storage of factors, it might be nice to just have that be a little more specific.
Yeah, I considered that. I considered a flag that was store factorizations, true, false, but then you also need to call A inverse when you're doing JVec and J transpose vec. And I think in a practical sense, you would store that factorization, you would do JVec and J transpose vec, but the way that the code is set up, it'll basically have to make a new factorization, give you JVec, dump it, then refactor it, and then do J transpose vec. So
my only comment, Deb, is just what do we call the keyword? I'm not suggesting you change any of the functionality. I'm just wondering what we call the keyword And because, for example, if you were doing a forward simulation, but you wanted to do a sensitivity calculation, you actually would want the factors stored. But it is still forward only in a sense. So my only question is, do we want to call that flag like store factors or store factorizations as opposed to forward only?
Yeah. Okay. Yeah, I guess I sort of did it to be consistent with what the mag problem is doing and the situation when we would use it. Because yeah, I guess when I think of store factorizations as true or false, I would think of that being something that would happen in both the forward simulation and in the inversion. If I'm gonna, in the simulation class, say store factorizations and say no, I would assume that that's gonna happen in I could apply that to a forward simulation and to an inversion.
And we could set it up to do that.
Yeah. I think there's a way to improve its efficiency. I mean, as of right now, you could do it, but it's not really optimized, right? Because it's gonna have to store that factorization, it's gonna create it, it's gonna compute JVec, and then instead of using that same one for J transpose vec, it's gonna dump it and then make a new one when it calls J transpose vec. So it's slower than it needs to be. There would need to be some work to optimize it if you wanted to include it in the inversion. But I mean, I think if we're inverting pretty standard FEM systems, they don't have like 21 frequencies, right? It's like 3 frequencies that you're inverting. So that might not be that very many factorizations. And for a small enough problem, you could store everything and invert it. In my case, I had 11 frequencies that I wanted to forward model, but the original way would make me store 11 factorizations of A inverse. So for what I want to do with the code right now, I'm happy just doing this for a forward simulation. And if people were actually using the code for a practical inversion, there might not be that many factorizations that need to be stored. So I don't know if we want to bother right now.
I would say we could have both, right? You could have a forward only switch that basically turn off the store factorization. And I agree with Joe. I mean, if someone wants to never store it, then, you know, JVec and JTVec would have to recompute it every time. And that's just what it is. You don't want to store it, you need to recompute it.
There could be a way that we would like short
Like a
circuit
soft,
if there's like if you need JT or J transpose times J times a vector, that would that's only like that'd be most applicable to like the frequency domain problem where it's separable, right?
On the JVec call, you store it and then you flush it on the JTVec.
Not necessarily, you just do it at the same time because it's like completely separable as far as that when you get to it.
Yeah.
So you do it for each frequency, you do J times like JVec or J transpose times JVec for each frequency and then go.
Yeah. Yeah, in terms of changing the code, it's a lot easier to just add a if statement in the loop for over frequencies, right?
Yeah, and that's totally fair. Just kind of thinking forward a bit, but sticking with forward only for now, especially because we've established that, I think makes sense. But just something to keep on the radar.
Yeah, try it. They have just implemented as forward only, put it in the for loop of the fields calculation, right? And then
yeah, I mean, I've done that already, and it works fine. And I've made a nice little verbose statement, so it'll say finish this frequency, and I mean, I'd like to bring it in because I don't want to have to work on like different hacky branches for everything that I'm trying to do, but Yeah, I mean, I'll make a little PR. I'll link it to the issues we have. If it's lightweight and everyone is cool with it, we'll bring it in. And if somebody
good.
has an idea that we just have to bring in, then like that's what the PR is for.
Sounds
Yep.
good.
Yeah. Yeah, and then I guess the last thing was about these code validations that I've been making for a Jupyter book. And Dom, you raised a pretty good point when we talked last, just about the long-term way that we would maintain this. So our SimPEG code is always evolving, which can sometimes lead to breaking some of these examples. So we want to maintain them so they're consistent with the up-to-date code. And some of these notebooks, and as we get more of them, they're a little bit heavier than the really basic examples, and they take longer to run. So we don't really want to trigger them or trigger that build every time we push to something. And so it would be nice to maybe sketch out a long-term plan to maintain these that doesn't really require a lot of hands-on maintenance. Something where, once we release an updated version of SimPEG that we would like install from pip or conda or something like that, that it would trigger those and just let us know if any of them are breaking. So we don't have to be constantly rebuilding it because they take a really long time, but it would be nice to have something tell us periodically whether or not something works.
I think the process there will then be to just set it up to be like a cron job where it runs once a month or something, where it downloads the latest SimPEG, set it up on GitHub Actions, just be like, okay, once a month, we're just going to double check that they all run still.
Yeah, that would be perfect. I mean, I am trying to make these examples small enough that you could run them on a modern laptop. I don't want to require any kind of cluster computing, but that would be perfect if just periodically it went and did that.
And another thing to think about too is we should get, because this is a separate repo, right?
Yes.
We should version it. And in the README, just always have a line that just says, this is the version of SimPEG and the version of Discretize that this was last checked on. And so even if, we release SimPEG tomorrow, it's fine that it's lagging behind. It just like sets that expectation that, yeah, it ran on SimPEG 0.14. If something breaks, we'll address it later, but then it's clear to us and everyone else which version of SimPEG and Discretize it's relying on.
Yeah, I guess that ups the level of, I guess, urgency to get Pymat Solver to be consistent with the latest, say, Anaconda download or basically Python 3.8, because I know for a fact that it's going to break because
Not just version these guys too, right? You can version everything, just like copy all your versions on your system and put it in the requirements, pin them.
Yeah, but
so
I tried downloading an Anaconda package that was, say, 3.8. Then I went through the versions and then downgraded MKL to, I guess, was it 2020.4 or 2019. Whatever the latest one that I'm allowed to use. And then it's going to go and look through and examine conflicts. And that version of MKL is old enough that all those other packages have undergone a lot of changes. And it's a nightmare, and it couldn't really.
Yeah, but the thing is that you have to put it in your requirement. All right, so you create an environment, an Anaconda environment, and you set it in your requirements so that you don't downgrade after the fact. You just set your environment with that version, and Anaconda is going to figure it out at the onset rather than trying to downgrade. Downgrading is dangerous for sure.
Yeah.
Don't downgrade.
I think the wrapper that I had written is pretty much close to usable. I haven't tested it too much, but it basically reproduces the functionality of the PyMKL at this point, and we can add more stuff onto it later. So we could just, I'll put that on the Conda Forge and get it on pip, or get it on PyPy and then put it to Conda Forge, and then we need to switch Pymat Solver to use that instead. Because Dom and John, I both gave it to you guys to work with, and you guys didn't have any issues installing it or anything, different versions at all, right?
Yeah. I have it actually. I have it running on my Linux system still. I've been using it, so
Okay,
it's all been working.
good.
All right. Actually, yeah, Joe, are we just figuring out the logo for the discretize API, or can we bring that in?
And that's basically what's happening after, yeah. Right now. So,
Yay.
okay, is there any other quick reports people want to chat about?
No,
No.
segues nicely into you.
Okay.
Well, I would just want to say that I stalled the refactorization regularization because PGI is such a beast. So I started the review, the pull request review on Thibaut's PGI refactoring thing. And then I pinged you a few places, Joe, if you could just chime in, just try to push that one first so that there's less for me to patch after. That would be great.
Okay. Okay. So I posted the link to the Google Doc where we had some logos on there. Let me share it really quick here. So these were some of the logos that we were looking at. Let's see, I'm not counting myself right now. So Dom had added a couple more there at the end. So he added this fourth and the fifth one here. I believe we had, 2 votes for this one. No, sorry. 2 votes for this one. Nothing for this one. 2 for this guy. And it looks like 4 people clicked on this one. Apparently. So according to Slack, this is the one that we're going to be going with, or at least something very close to that. So I will, if everyone is happy with that, I'm perfectly fine with that. It looks like a good discretized logo.
Yeah, I like that one too.
I will put it into vector graphics and I will probably go in through and make sure that the colors are the same that are matching the SimPEG colors. But other than that, it'll look pretty close to that, and we'll go with that. I'll vectorize it, get it going. Cool. So we're gonna go with this one. Cool.
Joe, where are you on the actual paper about the discretize? Is that kind of coming along?
It's getting there. I'm gonna be reaching out to some people to start parallelizing some tasks here. But mostly it had stalled for a bit with getting everything for the class up and going. But yeah. That'll be good. So we'll get that discretized logo in, we'll merge in all those the API stuff. Beautiful. We'll go back and look at those tutorials again really quick and make sure they're up to date, or make sure they're relevant with regards to the new API. And then looks good. Okay.
Is that going to be 1.0? Are we finally crossing?
Almost. I feel like I want to get these tetrahedral meshes in for 1.0.
Oh man, never ends. Never.
I'll be happy. I'll be happy. What would we be at? Oh. I don't even know if the API warrants a 0.8. Because we're at 0.7 now. There's no functionality change between the two. It's just a lot more documented. Maybe we'll just do a patch. I don't know. We'll see.
Just a number, right?
Yeah, it's just a number. Okay. So then the other times is we can I think it's thinking more about the alternating times for meetings. or towards the afternoon in the Pacific time for some, to allow for, you know, Australia, New Zealand, people on that side of the globe to join in. So that would be more afternoon time for us Pacific people. I know most of the days I am busier in the afternoon personally, at least like after, I'm usually free after 2 o'clock on Wednesday through Friday. So it doesn't necessarily have to be on the same day. I mean, it would be easier on the same day, just like, oh, it's Wednesday, and I go SimPEG meeting, we just switch times back and forth. Are there any other big, like, oh, I can't do Wednesday at all, except for this time? Or if not, we'll probably put a poll up on the meetings channel in the Slack, just looking for some other times. But is aiming for Wednesday at least a reasonable Wednesday afternoon at some point, a reasonable thing? Okay,
Fine by me.
sounds good. So we'll aim for around that time, and then, but the idea would be we'd switch back and forth between.
That was my question. Do you want to continuously switch back and forth, or say the first and the third Wednesday is morning at the and first, something like this, that you don't have to check the calendar and you know it's a third Wednesday of the month, so it's going to be in the morning.
Yeah, that sounds good. We'll get into that, right? First and third, second and fourth. That sounds good.
And then there might be every now and then one off where you can have something else.
And we can keep the SimPEG calendar for that so that everyone can add that to your calendars, because I know myself, I will forget which week it is.
Okay. Sounds good. Excellent. Anything else anyone would like to share before we call it a day? No? Good, good.
I call it a day. You go to work.
Call it a morning. How about that?
See you next time.
Yeah,
Bye,
see you next
everyone.
time. Bye.